Okay. So we are here. It's supposed to finish 3.3 today. That should not be that long. I was going to do some of the limit problems at the very end. Okay, and then I'll sneak in maybe very little of section 3.4, the chain rule. I'll just say what it is, maybe do one problem involving it, and then I'll go ahead and give you the quiz. Okay, so as usual for quizzes, I'll put you into your breakout rooms. Prasanna and I will bounce here and there between the breakout rooms. You don't have to turn it in today. It's not due until our next class meeting, which is, of course, next Monday at 12:10. So you have the whole weekend to work on it. But if you want to submit it faster, that's perfectly fine also. Okay. Right, so we are here. Okay, so I was done lecturing on the derivatives of the trig functions here, but I was working on 39 to 45, some of those limit problems. So I'll show those to you and then sneak in a very little bit of 3.4. Okay. So getting back to the text. So what you want to work with again for the trig functions are these. So try to get comfortable with that limit. Limit as theta approaches 0 of sine theta over theta equals 1. All I can say is we did it in class. That happened to be question 9 on the last exam. But again, if worst comes to worst, you know, you could always plug in this expression 0.00001. Make sure you're in radians, and you'll get something like 0.9999, and you can see, okay, the limit's about 1. Right? And then we're using all of these trig derivatives, right? So know that derivative of sine is a cosine, derivative of cosine is negative sine, derivative of tangent is secant squared, derivative of cotangent is negative cosecant squared, derivative of secant is secant x tangent x, derivative of cosecant is negative cosecant x cotangent x. You can put it on your cheat sheet. Again, if we were meeting face to face, I would make you guys memorize it, but we're supposed to make things a little bit easier on you. That's how I'm making it easier on you. All right, so, but I'm going to go back and look at this identity. Okay, the key thing is this angle has to match this angle. It doesn't quite have to match this angle as long as this angle goes to 0. Okay, so pretend this was 5 theta. This has to be 5 theta. But if this is theta, that's okay, because as theta approaches 0, 5 theta also approaches 0. So theoretically, that and that and that are all the same, but you're allowed to have this one just be theta. But these two definitely have to match. Okay, what's going to happen a lot of times is that might be 4 theta. This has to be 4 theta. If this is just theta, that's fine, because as theta approaches 0, 4 theta also approaches 0. So that's going to be okay. All right, so we did one problem last time with that, and I'll do a couple more. And then that was pretty much about it. Okay, 3.3, problem number 41, please. It was a limit as t approaches 0 of tangent of 6t divided by sine of 2t. All right? And of course, if you notice right away, you can't directly substitute because you'll be plugging in 0 here. The sine of 0 is 0. You have a 0 in the denominator. That's not allowed. But the first thing to do is write this as sine over cosine. So tangent 6t, put a sine of 6t on top, cosine of 6t on bottom, and another sine of 2t. Right? Now, the key things here are this one and this one. This doesn't really bother me at all. If I plug in 0 here, I'll have the cosine of 6 times 0, which is 0. That's 1. So that doesn't bother me. The things that bother me are these two guys. Right? All right. So in order for me to use the formula, okay, so I split out the 1 over cosine of 6t. Okay, the limit of a product is a product of the limit, so to speak. Okay, so I'm going to write it like this temporarily. So I'm going to write it as 3 limits. Limit as t approaches 0 of 1 over cosine 6t times limit as t approaches 0 sine of 6t divided by limit t approaches 0 sine of 2t. Okay, so I break this up into 3 limits. Limit of that times the limit of this and divided by the limit of this. It's all. The limit of a product is the product of the limits. Limit of a quotient is the quotient of the limits. So this is valid. Okay, again, this doesn't bother me. I can plug in directly. I'll get the cosine of 0, which is 1. Okay, now, here's the strategy. From what we said earlier, I need this thing here to be 6t to match that 6t. I need this to be 2t to match that 2t. That's not going to balance, but I can always worry about the balance later. Okay, so again, this angle has to match this angle. There's no way you want to fiddle with sine of 6t. Normally, you leave that alone. We can fiddle with this. All right, so I just put a 6t there. I just put a 2t here in order to make everything match. Okay? Because now I can deal with that limit. I can deal with this limit. But it's not fair. I put 6t here and 2t here. So what would make it fair? If I put an extra 1/3 like so. Okay, so now in effect, what I've done in effect is to divide the top and the bottom here by 6t, which is a legitimate step. I've multiplied this whole expression by 1 in the form of 1 over 6t divided by 1 over 6t. I split this up into 2t, 2t, because I need that to use that theorem. And I need this 6t to match this 6t. And again, technically this should be 6t, but that's okay. If t approaches 0, so does 6t. Okay? If I plug in t as 0.1, 0.01, 0.001, 0.0001, what happens if you multiply by 6? Well, then you would have 0.6, 0.06, 0.006, 0.006. That also approaches 0. And likewise, very technically, that should be a 2. But if t approaches 0, 2t also approaches 0. So let t approach 0, right? 0.1, 0.01, 0.001, 0.001. Then what happens to 2t? 2t would be 0.2, 0.02, 0.002, 0.002. They approach 0. And now where does 1/3 come from? It's in order to balance everything, right? So I'll use this, and I'll split this out. Let's see. In this ultimate fraction, this great big fraction, I'm dividing by 1/3. Right? It's blah, 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 divided by 1/3. So if I divide by 1/3, I multiply by 3. So I have a 3 in front now. And now here we go. This, by direct substitution, is 1. Put in t is 0. I'm taking the cosine of 0, which is 1. 1 over 1 is 1. And like I was explaining, even though you have that, I snuck in a 6 in red, and I stuck in a 2 in red. Again, if t approaches 0, so does 6t. And when t approaches 0, so does 2t. So now these are exactly according to the rule that I just showed you, right? It fits this. That angle matches that angle, which matches that angle. So therefore, by that logic, let's see, where am I? This limit is 1. This limit is 1. And this limit is 1. So I have 3 times 1 times 1 divided by 1. So the final answer is 3, ultimately. All right, it's a little bit tricky, but that's the way that one works. Okay, then the last one I wanted to show you was 45. Limit as theta approaches 0, sine theta over theta plus tangent theta. All right, so write tangent as sine over the cosine. Okay. And now, once again, I got to get a theta there, so I'll divide top and bottom by theta. Okay, so temporarily ignore the red. This is the same as the original, right? Right over here, sine of theta, leave that alone. There's that theta. And here's tangent, right? Tangent theta is sine theta over cosine theta. So in order for me to use that identity, I divide top and bottom by theta. Okay, so this whole thing is divided by theta. So this is sine theta over theta. That's what I want. This is theta over theta, which is 1. Okay. What I'm trying to illustrate here is this. If you have sine theta over cosine theta, the whole thing divided by theta, you're allowed to slide the cosine of theta down and join over here. Okay. In other words, what I'm trying to say is this. Have you ever seen something like this? If you ever have a over b divided by c, you're allowed to slide the b down and make it look like that. Okay, so if you have a fraction on top over c, that denominator here can just slide down a over bc. Okay? What's the justification of that? Well, you can multiply top and bottom by b, right? And then these will cancel out, and then you have a over bc. Okay, so what I'm really trying to say is that you're allowed to just slide down this thing over here. Sine over cosine, the whole thing divided by theta. Cosine theta can come down. So in other words, it's going to look like this now. Limit theta approaches 0. Sine theta over theta is on top. That's what I want. Okay. Limit theta approaches 0 of 1. That's fine. Okay. And again, I'm using the fact that the limit of a quotient is the quotient of the limits. Limit of a sum is the sum of the limits. So I'm putting a limb here, and a limb here. So that's what I want. And then here I have theta over theta, which is 1. All right, so what did we say? We have sine theta over theta cosine theta. I can break that up into limit theta approaches 0, sine theta over theta, limit theta approaches 0, 1 over cosine theta. Okay? So again, theoretically, this is sine theta over theta cosine theta. I'm breaking it up into sine theta over theta and 1 over cosine theta. All right, now I have everything that I want. This is 1. This is 1. This is 1. The limit at theta approaches 0 of a constant is 1. I mean, this doesn't depend on theta. So that's still 1. And by direct substitution, this is 1. If you plug in 0, I've got the cosine of 0, which is 1. 1 over 1 is 1. Okay, so I got a bunch of 1s. 1 divided by 1 plus 1 times 1, which is 1 over 1 plus 1. So final answer is 1/2. All right. Okay, so that's as much as I was going to do in 3.3. I'm basically done with 3.3, and we're on par for the schedule, exactly on schedule. I'll sneak in just a little bit of 3.4. It'll just help me out on Monday. I'll give you the rule. It's called the chain rule. Okay, so I'll show you the chain rule, maybe do one problem, then I'll stop and give you the quiz. Okay? All right, so 3.4, the next rule is something called the chain rule, C-H-A-I-N. Chain rule, 197. It tells you how to take the derivative of a composition, okay, like f of g of x. Remember you did a lot of f of g in algebra and pre-calculus maybe, right? F of g. Okay. Something like this, square root of x squared plus 1. This is a composition of functions. There are two functions here. There's a square root function, and there's also x squared plus 1. So how do we differentiate this? Again, what is differentiation? It's a process of taking the derivative. Okay? And we won't prove this theorem, we'll just state it. I will give you a plausibility argument, though, and the plausibility argument is based on the Leibniz notation. Okay, so on page 198, the chain rule, we want to talk about how to differentiate a composition like f of g of x. Okay, now let me show you this, and I want you to see this is very plausible if you think of quote unquote canceling stuff out. Dy dx is equal to dy du dx. Okay? And it kind of looks like if you cancel out the du's, then you have dy dx, right? I mean, that's sort of a way to memorize it. That's sort of what goes on with the proof. I'm not going to show you the proof. You can look at it if you want to. Okay? But that seems plausible, right? By using the Leibniz notation, the d notation, you can say, okay, dy dx, dy du, du dx. It kind of looks like you can cancel out the du's, right? Okay, so how do you differentiate something that looks like f of g of x? Okay, so you want capital F prime of x. Okay, if I temporarily call this u, okay, call g of x u, then to find dy dx, if I take the derivative of the original function with respect to u, that would be what we normally call dy du. If this was a u, we would just say dy du. And then I multiply by du dx. Well, that's the derivative of the inside function with respect to x. Okay, so if I temporarily call this g of x u, okay, then if I take the derivative with respect to u, that would be dy du. Okay, but I don't want dy du, I want dy dx. Okay, if this had been u, then u prime would be du dx. All right, so dy du is f prime of u. So behind my pen, pretend it's u. Okay, but what is the u? I just defined it as being g of x. And then du dx is what we normally call g prime of x. Okay, so here is the chain rule. Now, if you understood absolutely nothing of what I was saying, that's okay. All right, I'm supposed to at least say it. All right, so when you have the Leibniz notation, dy dx is dy du du dx. Okay, that's the chain rule. It kind of looks like you can cross up the du's. Okay, most of the time, though, we'll be looking like this. Right, so here's the chain rule. If you want to put it in your cheat sheet, you may. But here's the idea of the chain rule. Capital F prime of x. Okay, so first you take the derivative of the outside function. There's an outside and inside function, right? F and g. You differentiate the outside function with respect to the inside function. That's a language we use. Say f prime of g of x. And then times the derivative of the inside function, g prime of x. Okay, you just chain them together. That's why it's called the chain rule. Okay, this is the easiest case scenario when there's only two functions. You can use the chain rule when you have 3, 4, 5 functions. Okay, I think part of the homework there was maybe one function that had 5 functions deep, where there were 5 functions. You just keep chaining them together. Just keep taking the derivative of the outside function with respect to the inside, and you multiply with the derivative of the inside function and keep going from there. Okay, so bottom line, there's an outside function and an inside function. Okay, you take the derivative of the outside function first with respect to the inside function. That's the language we say. And then times the derivative of the inside function. Okay, that's called the chain rule. Okay, I will show you just one example, and then I'm pretty much done. Okay, we'll do a lot more chain rule next week on Monday. I'm on par. If I were to stop and do nothing, I'm on par on the schedule, but I might as well get a little bit ahead in case I fall behind or my internet goes down again or whatnot. Okay, so I'll try to show you just one simple example. Except I don't know what happened to the example that I had. Here we are. I just totally made this up. Y equals 2x squared minus 5x plus 7 raised to the third power. Okay, so it's not just x cubed. It's a more complicated function cubed. It's blah, blah, blah cubed. Okay, now we know how to differentiate x cubed, but what do you have? Something much more complicated. Okay, so there are two functions, the cubic function and 2x squared plus 5x minus 7. So the chain rule says take the derivative of the outside function. What is the outside function? The cubing function. Okay, so you go like this first. 3 times, copy this stuff down, squared. Okay, so that looks like the power root, right? 3 times 2x squared plus 5x minus 7 squared. And now the chain rule says it's times the derivative of the inside function. Okay, so what's the derivative of the inside function? 4x plus 5. So that's how the chain rule works. Okay, so one more time, it's not just x cubed. If it was just x cubed, the derivative is 3x squared. So what if you have something more complicated cubed? Okay, well, you start off the same way. You go 3, blah, blah, blah squared. And then the chain rule says times the derivative of the inside function. So that means you multiply by 4x plus 5. All right, so that's just an introduction to the chain rule. We will do a lot more on Monday, but I'm going to stop now and give you a quiz. Okay, and let me check the chat real quickly. So maybe Prasanna already got it. I'm not sure. Do that real quickly. Okay, got that. 3.343. Okay, I don't have time to do that. Maybe Prasanna gave that to you, Joey. If not, you can ask me later, but we shall see. Okay, otherwise I think that's about it. All right, okay, so I'll give you the quiz right now. So everybody get out your cell phones and take a picture of the quiz as soon as I get back to share here. So bear with me for a moment as I try to get that ready. Okay, here we go. So go ahead and take a picture. We're still recording, so worst case scenario, it's on the video. Okay, find the derivatives. I'll even read it just in case. First one, f of x equals 3x squared minus 5x plus 6. 3x squared minus 5x plus 6. Number two, y equals 7 e to the x minus 2 square root of x minus 1 over x squared. One more time, 7 e to the x minus 2 square root of x minus 1 over x squared. Number three, find d dx of x squared e to the x. Basically means find a derivative. X squared e to the x, so you should know what rule that is. Number four, f of x equals 3x minus 10 over 5x plus 16. One more time, 3x minus 10 over 5x plus 16. You should be able to guess what rule that is. And 5 is another one of those, find the equation of the tangent to the curve. So you know what that means, right? Put it into y minus y1 equals m times x minus x1 to give us the best possible point, the origin. Okay, so y equals 4 e to the x minus 4 at the origin 0, 0. Okay, so I think that's enough time. Worst comes to worst, you can ask one of your breakout room roommates, or even worse than that, you've still got the video. You can look at the video. Okay, it's due class beginning on Monday at 12:10, so you can work on it the whole weekend. All right, so I think everybody's got it. Let me stop the share. I'll set up your breakout rooms. Go ahead and get started with it. It'll take me a moment. Sana and I will bounce around and see how you're doing. But when you're good, when you're comfortable with what you got, then you can just go ahead and leave and have a good weekend. All right. So go ahead and get started. I'll get you guys going. Okay, you've been invited to join our breakout room. So can everybody please go to your breakout room now? Okay, Norman and William, can you join your breakout room, please? See, Norman, you should join your breakout room, please. Francisco, did you have a question?
Yeah, just kind of wanted to ask, since I just let my group know if they did have any questions on the quiz. I dropped in my email just in case, since Fridays I do leave to work a little earlier. So, is that even okay? Do I still get points for that, or does that not? Do I lose participation points?
Yeah. Did you email me? You said?
No. That I actually talked to my classmates right now in the group and informed them that since I do leave to work a little bit early on Fridays, that
Yeah.
went ahead and dropped off my email in case if they had any questions and just reach me out as well. I can help them out
No,
with
that's
that.
fine. Don't worry about
Okay.
it. Yeah, you're good.
All right.
Go
Sweet.
ahead and
Well, have a good one. Have a good weekend.
sure. Okay,
Thank you.
have a good weekend. Yeah.
Sorry, teacher, I had an internet connection. That's why I just hopped on to the class. So
Okay.
can I just take the question paper and then I'll just send it to you?
Yeah, that's okay. I'll mark you here because don't worry.
Okay, so
Okay.
which group am I in? Or
Okay,
I don't
I'll
need-
assign you to one, okay? Hang on. I'll get you in. Okay. You should be able to join group 3. Mingjun, did you just join?
Yes.
Okay. We're taking the quiz now. Let me try to show it to you, okay? Do you have your cell phone?
Yes. Sorry, I was outside, so I didn't
Okay.
join the class.
Okay, let me give you the quiz. Give me a moment to get it. Okay, can you see it?
Oh yes, yes. Thank you.
Okay, do you have it?
Yes.
Okay. I will put you in a room also. So just bear with me. I'm going to assign you to one of the breakout rooms, okay?
Okay.
Okay, I think you can join a group now.